Another example. Let's take again our f here from R into R. The definition is f at x is x plus 1 divided by x plus 2. The question is find the inverse of f. Like we did before, let us set y to be x plus 1 over x plus 2. Right? If we do this, we will have that y into x plus 2 is equal to x plus 1. Please remember here that we are assuming we are dealing with the values of x for which this function is defined. So here we are taking x from the domain of f. And if you observe well, f is not defined on the whole of R. For instance, of course, precisely, at x equal minus 2, we will have 0. And so minus 2 is not a member of the domain of this function. Correct. If this is true, we solve for x. And so we have x multiplied by y plus 2y is the same as x plus 1. And this gives that 2y minus 1 is x minus x multiplied by y. From here we get that 2y minus 1 is equal to x. We factor x out here, we get 1 minus y. And this gives us that x alone is 2y minus 1 divided by 1 minus y. So we have gotten a new function. So our claim is that f minus 1 of x is the function defined in this way, 2x minus 1 over 1 minus y. Again, I explained that using x and y is just for ease of understanding. They are dummy variables. Okay, so here I'm taking y. When I mean x here, I still mean x coming from this codomain. Now this is our new function. Observe again that the domain of this new function does not include y equal 1. Okay, because at y equal 1 we have 0 and then there's a problem here. Sorry, it doesn't include x equal 1 rather. Okay, so this is what we got as our inverse function. And so we must check that this is true, meaning we must check that f composed with f inverse acting on x will give us x, the identity map. So it will also check that f minus 1 composed with from left now acting on x will also give us an identity map. When we do this and then we have x in each case, then we have shown that this function defined this way is the inverse of this particular function. And so we do this composition next. F composed with f inverse on x is f acting on f inverse of x, and this is f acting on 2x minus 1 over 1 minus x. But we know how f behaves. What f does is, for anybody you give, it will take x plus 1 divided by x plus 2. So this is going to give us, this is our x here. So this is going to give us 2x minus 1 over 1 minus x. We add 1 and divide by 2x minus 1 over 1 minus x. We add 2. Alright. When we solve this, then this is going to give us 2x minus 1 plus 1 minus x divided by, here we're going to get 2x minus 1 plus 2 minus 2x divided by 1 minus x. This is nothing but this and this will go, so we have x divided by, please pardon, this is divided by 1 minus x. Please let me adjust this appropriately. So this is 2x minus 1 plus 1 over 1 minus x divided by 2x minus 1 plus 2 minus 2x divided by 1 minus x. Correct. So now this is going to give us this is plus 1 minus x. Okay, so this is going to give us this will give us x over 1 minus x divided by this will go, so we have 1 divided by 1 minus x. At the end of the day, this returns x. And that says that f composed with f minus 1 acting on x is x. So we have composed from the right and we got x. Let's compose again from the left to see what we are going to get.